What is computational thinking? Computational thinking is a thinking process that involves formulating a problem and expressing its solution in such a way it can be carried out by the computer, human, or machine. Computational thinking consists of four cornerstones: decomposition, pattern recognition, abstraction, algorithms design. The first step of computational thinking is decomposition. It involves breaking down a complex problem into smaller, simpler, more manageable problems. For example, take this mathematics problem. Find the sum of all integers from 1 to 100. It means 1 plus 2 plus 3 plus 4 and so forth. Continue this pattern until adding number 100. How can we solve this problem? If we add the numbers sequentially, such as 1 plus 2 equals 3, 3 plus 3 equals 6, 6 plus 4 equals 10. This is going to take a very long time, and it is really hard to keep track of it in our head. The best way to attack that problem is, break down the sum into smaller and easy addition. 1 plus 100 equals 101, 2 plus 99 equals 101, 3 plus 98 equals 101, and so forth, until the last addition, 50 plus 51 equals 101. The second step of computational thinking is pattern recognition. It is to identify patterns or trends within a problem. Let's return to the problem we've started in step 1. Find the sum of all integers from 1 to 100. What pattern do we see? If we take the sum of the first number and the last number, we get 101, and all the other pairs have the same sum. And we figure out that the pattern repeats for 50 times. And we know that 50 equals 100 divided by 2. In other words, we get 50 by dividing the last number by 2. Gotcha. The third step of computational thinking process is abstraction. Abstraction suggests we identify specific similarities and differences among similar problems to work toward a solution. In our original problem, we had to find the sum of all integers from 1 to 100. Let's look for similarities and differences. All the pairs have the same sum, so we can write the solution as an equation. Sum of each pair. Multiply by number of pairs. The final step of computational thinking process is to design an algorithms as the solution. Algorithms is a set of step-by-step well-defined instructions for solving the problem. How to represent algorithms with clarity in such a way people can understand it easily. There are some methods practiced by people. However, in this course we will practice only two methods. First, we are using pseudocode. What is pseudocode? It is a written outline of the algorithms. It is a simple way of describing programming code in simple plain English. Pseudocode is not actual programming language. It uses short phrases to write code for programs before you actually create it in a specific programming language. Second, we are using flowchart. Flowchart is a diagram of the steps in an algorithms. We will discuss later in detail what flowchart is. Now let's use pseudocode to write our algorithms to find the sum of all integers from 1 to any positive integer n. Step 1, start. It means the process starts. Step 2, input n. It means the algorithms asks for the value of n. Step 3, sum equals to 1 plus n times n divided by 2. Step 4, display the value of sum as output. Step 5, the process stopped. A variable is a named piece of computer memory, containing some information inside. Think of a variable as a box with a name, where we can store something for retrieval and use later. We create, edit and delete variables, as much as we need in our tasks. A simple variable can hold only one value at a time. When a new value is assigned, the old value is lost and cannot be recovered. Now let's try to calculate the value of each variable a, b, c at the end of step 4, 5, and 6. In step 4, the process is going to add first the value of the variable a, plus the value of the variable b. And then store the result in the variable a. It is clear that now the value of the variable a is 10. In step 5, the process is going to add the value of the variable a, plus the value of the variable b, like in step 4. But now the value of the variable a is not 7. A is 10. Therefore, from the equation a plus b, we get 10 plus 3 equals 13. After that, this result 13 is stored in variable c. So, c equals 13. Next, in step 6, the process will do 13 minus 10, plus 3, and then store the result in variable b. Now, b equals 6. Now let's continue to learn how to draw a flowchart. When we are drawing a flowchart, we are using some graphical symbols. Each symbol has a special meaning. In this slide, there are some most common flowchart symbols. And it is very important that you have to memorize these symbols, and understand the meaning of those symbols as well. This slide displays the flowchart of the sum of all integers from 1 to n. To put an algorithm's into action by a computer, we have to translate an algorithms into a program, using a programming language. Snap is a programming language. Unlike most programming languages, though, Snap is a visual language. So, instead of writing a program using the keyboard, the Snap programmer uses the same drag-and-drop interface, familiar to computer users. By using a programming language, you can tell a computer what you want it to do. Let's start to write a program using Snap. To write a program in Snap, we need to visit the website of Snap. Use any web browser which you want. The URL you have to type in is snap.berkeley.edu.